Hello everyone, welcome to NCERT Simplified, and we are doing chapter number 10 of class 11 physics. This is chapter number 10, mechanical properties of fluids. So obviously we are discussing about fluids, and in the previous video we discussed about pressure, and we obtained what is the formula of pressure. Okay, its unit is dimension. Then we have discussed about density, relative density we discussed. Okay, and after that we discussed Pascal's law. Okay, so what was Pascal's law? It was when we apply pressure to when a pressure is applied to an enclosed liquid, it is transmitted undiminished in all the direction in the fluid. Okay, so now in this video we'll just understand it in more detail. I'll read the NCERT and explain it to you. Okay, so let's start Pascal's law. Okay, so now the French scientist Blaise Pascal observed that the pressure in the fluid at rest is the same at all points if they are at the same height. Okay, so it's a very important point and very the thing you must know. Okay, that if you take a liquid, then at all the same point, at same height, all the points have same pressure. Okay, so there are certain experiments you can do on this. Very simple experiment you can do. What you can do, you can fill a water bottle with I'll just try to make a water bottle, and you can fill it with water, and then you can make small orifice in this water bottle at the very same height. Okay, at the same level. Now you pour water from above, fill the water bottle, and what you'll observe, the jets coming out from this water bottle, they will going to a same distance. So this proves that the points in a liquid having same level have same pressure. Okay, so coming back to this is the thing that he mentioned. Okay, and we are now discussing this. Okay, in a simple way. Okay, so now figure 10.2 shows an element in the interior of a fluid at rest. Okay, so we had considered an element. This is a fluid, and we are considering an element of this fluid, and this fluid is red. Just remember it. This element A, B, C, D, E, F. You can see this element A, B, C. Okay, A, B, C, and D, E, F. This is the element. Okay, is in the form of a right angled prism. From the clear it is mentioned, it is clear that it is a right angle prism. Okay, this is right angle here is a prism. Okay, now, and we have this is the inside of a fluid. Okay, an element we have considered. In principle, this prismatic element is very small, so that every part of it can be considered at the same depth from the liquid surface, and therefore the effect of the gravity is the same at all this point. Okay, so you can see, if you see the figure, they have drawn it little bigger. Okay, but we have to consider it very small element. Okay, so they are at the same height. The effect of gravity at all the points on this element, water element or the fluid element, is same. Okay, but in figure they have shown it bigger, just to make it more clear. Okay, so now yeah, so for clarity we have enlarged this element. Okay, as I told you this, the forces on this element are those exerted by the rest of the fluid, and they must be normal to the surface of the element as discussed above. Okay, so on this element the forces must be normal, as we mentioned in the previous video. If the forces are not normal, then what will happen? The object will also, okay, you can consider this an object. This part of the rest of the fluid will exert force on this element. Okay, and this element will exert force on rest of the element, and if the forces are not normal, then there will be some component of that will be horizontal, and what will happen then in that case, the fluid will be flowing, rest of the fluid will be flowing, and we know the fluid is at rest, so it cannot be possible. So the these forces that the rest of the fluid is exerting on this element, we can consider this element as an object. Okay, so the rest of the fluid is exerting force on this element of the fluid, and that is normal to the object or the fluid element. Okay, now thus the fluid exert pressure PA, PB and PC, this element of area corresponding to, okay, yes, so this is P on, okay, on this element of area corresponding normal forces is FA, FB and FC as shown in figure. Okay, so the fluid is exerting force on this area element, FA on this side, FB on this side and FC on this side. All three forces are normal to the surface of that element. Okay, the right angled prism. Okay, now the three faces, these are name of the three faces. We are given the name capital A, capital B, B and capital C, capital A, C. Okay, and now you see, then FB sin theta is equal to FC and FB cos theta is equal to FC. Okay, now this FB can be resolved into two components. One will be, suppose this is angle theta. Okay, here it is theta. Okay, with the vertical it make theta angle, so I can make it into component. This will be FB cos theta downward, and this is FB sin theta horizontal. So this is FB cos theta here, and this will be FB sin theta. And you see this fluid is in equilibrium, so the net force acting on this element should be 0. That means the FB sin theta should balance FC, so FB sin theta should be equal to FC, and this vertical component FB cos theta must be equal to FA. So that is given here. FB sin theta is equal to FC and FB cos theta is equal to FA by equilibrium. Similar to force, we can resolve area vector into components. Okay, and by geometry, AB sin theta will be equal to AC and AB cos theta will be equal to AA. Okay, so now we can divide these two equations. Okay, and what we'll get on dividing this, we will get what? FB upon AB is equal to FC upon AC. Similarly here, FB upon AB equal to FA upon A. So we can get FB upon AB is equal to FC upon AC is equal to FA upon AE. So the pressure on all the 3 points, all the 3 areas are equal. Okay, so because the 3 points we considered were at the same height. Okay, as we consider the element to be very small, so this proves that the pressure exerted is same is on in all the direction in a fluid at rest. It again reminds us that like other types of stress, pressure is not a vector quantity. Okay, so as we have seen earlier, what was pressure earlier when we discussed pressure? It was the force thrust acting normal to the surface. Okay, so there is no direction is fixed for pressure. Okay, so it is not a vector quantity, it's a scalar quantity. Here also no direction can be assigned to it. The force again an area within a fluid at rest, and the pressure is normal to the area. Okay, it is always normal to the area. Okay, regardless of the ordination of area. That's why pressure is a scalar quantity. Okay, now consider a fluid element in the form of a horizontal bar of uniform cross section. The bar is in equilibrium. Okay, again we can consider a fluid element in shape of a horizontal bar like this in the fluid. Okay, the horizontal forces acting on at its two ends must be balanced, or the balance pressure at the two ends should be equal. Just like we had proved, like this is the horizontal bar, the horizontal forces should be balanced because the fluid is at rest. Okay, this proves that the liquid in equilibrium, the pressure is same at all the point in a horizontal plane. Okay, so this is how we can prove this. Suppose the pressure were not equal in different parts of the fluid, then there would be a flow as the liquid will have some net force acting on it. Okay, so if there was any pressure difference here, this part, the pressure is more here and pressure is less here, what would have happened? Then the liquid would have flowed. It will not be at rest. Okay, so this is how it proves that pressure at at the same point in a liquid, at the same level in a liquid, is equal. Yes, hence in the absence of flow, the pressure in the fluid must be same everywhere. Wind is flow of air due to pressure difference. Okay, and you know why wind flows whenever there is a difference in pressure. A very common theory that you know, then when the sunlight falls on the land, that part is heated and the air rises there, and the pressure there is low. So the pressure from the wind air from the high pressure region, that is the cool places, will come and will fill that area. So this is how wind flow, because of the pressure difference. Okay, so now then we can discuss the variation of pressure with depth. Okay, so now